Okay, thanks for the intro there, Andre. My name's Steve Thwaites. I work for Puppet, and I'm here to talk to you about automating infrastructure and how having configuration management handle your infrastructure can play a critical role on a journey to achieving a kind of continuous delivery workflow. So we've had plenty of talks today about what continuous delivery is. I just want to kind of re-highlight a few of those themes really in the context of what I'm going to talk about. So continuous delivery is about having smaller incremental changes being tested automatically and being deployed automatically, so that you can react faster to market conditions, so that each build that comes out is deployable, and if you need a change in direction or if you need a change in your requirements, then you can change tack without having to change your entire workload. It allows faster innovation, so having several people collaborate and make builds and having every commit be tested allows faster innovation and faster prototyping. You can find and fix bugs faster because you can see with automated testing how a particular build may cause issues. And of course, you're just closing up that feedback loop. So every time everything's coming through as a new commit, as a new version of software, you can find out whether or not that's going to work. But of course, everyone here is running software on infrastructure, and adopting continuous delivery to perfect the art of developing software doesn't actually mean you're done at that stage. It's also about maintaining and configuring the infrastructure beneath it. So having all of that speed and agility in achieving excellent software and developing that in a continuous delivery workflow doesn't get you very far if your environments are out of step, if your the laptop that you work on, everything works fine there, you take it to a newer development environment or indeed in production and it breaks. So it's a common quote we hear like, it was working when it was in the development environment. I'm not sure what went wrong. There'll be some important difference between each of your environments which is causing your software to break. So infrastructure does matter a great deal for software, the software that you'll be developing. So we need to make sure this stuff is always working in production. It's not a question of whether or not, as things move through environments, are the changes being accounted for? We need to make sure it is always working by the time things get to production. Things don't proceed into production if they're not going to work beforehand. And there's no gamble or risk involved in actually moving from one environment to another. We want to get from the time where a piece of software is done to actually having it running on a test infrastructure and on a production infrastructure as well. And automating that is the only way, really, to get to that position quickly. Knowing whether or not an infrastructure change is going to change your release. So having your software testing running in parallel alongside your infrastructure testing can give you a high degree of confidence that any underlying infrastructure changes isn't going to break your software when you release. And of course, when you want to roll back and actually look back through a history of changes, not just in your software, but in your infrastructure, can you go back and test that in an isolated environment if that's necessary? Now, I come from an operations background, an infrastructure background, and generally speaking, we have to choose between two out of these three things. We have to kind of do things quickly, do things reliably, or get some sleep. Usually those things, you can only choose two of those things. And generally speaking, sleep is the one to go. Or sometimes it's all three. You're trying to maintain and not doing any of them successfully. So as an IT function and as systems administrators, we need to kind of step up and kind of adopt a lot of these now mature workflows, these kind of methodologies that are working well in software development so that we can react as quickly as software needs to these days. Now, doing things manually is costly. I think these themes come up time and time again when I speak to people about configuration management. It's really about doing things quickly and actually making sure that from the moment you have the idea or the approval to proceed with a change, actually getting to that extremely quickly. And of course, productivity. I've been involved in doing, when I started in IT, it was very much a manual operation. I used to sit in front of a stack of paper. It was my build process and run through that and pop disks into drives and sit there and run shell commands until the build was done. And of course, insights, having a good grip on what actually is out there in your fleet, not just on day 0 or day 1 when you actually deploy the infrastructure, but years hence, when this infrastructure is out in the field, do you know that things are in a compliant state? Are things in the way that they should be in a functioning environment? So a quick poll of the room, I'd be interested to know, for those of you who know how your operations are done in your organizations, how many of you are running your software on systems which are manually configured by someone, by a human being pushing buttons? Cool, don't be shy. Okay, and for those of you who use some sort of scripting in order to get that work done as well, some sort of scripted installation, scripted configuration of systems, anyone? Yeah, there's another good portion, yeah. Golden images, so people using VMware templates or some sort of gold build ISO image or something for building your systems, anyone? Yeah. And all these sort of what we like to call legacy tools, but these large kind of management infrastructures that essentially script things for you through a point-and-click interface. So these these automation management systems. Is anyone using any of them? From the big software vendors, I won't call them out. So I mean, this slide kind of nicely sums up the sort of history of configuration management. I mean, that's certainly how things have been handled over the last decades. The problem is none of these things work well enough. They can't really keep up with the speed of innovation. They can't keep up with the workload that operations now has to deal with. So a new approach is required. So I'm here to talk to you about Puppet, of course. So just a few bits of information first about Puppet, about the buzz around Puppet, of course, right? So we have a lot of interest at the moment. There's lots of people downloading our software. We think we don't know, but we think around 20,000 businesses are using Puppet in one form or another. There are 2,500 community modules. These are the configuration packages that you can download from Puppet for free. They're available on what's called the Puppet Forge. We have multiple user groups worldwide. We're starting one here in Paris as well. There's many contributions made on GitHub. It's an open source project fundamentally. A lot of the work that goes into Puppet comes from open source contributions from the community. And we have multiple Puppet enterprise customers. So rather like CloudBees, we have an enterprise distribution of our software with extra functionality. And we're growing. So I joined here in Europe as an early employee last year, and there's now 20 of us based in our office in London. So what's different about the approach that Puppet takes to configuration? It's more about convergence with a desired state than a scripted set of instructions, a process to be followed in a procedure. So whereas in a script, it'll start at the top and interpret the script and execute each of the instructions in turn, Puppet is more about defining an end state to which you want Puppet to work towards. So instead of saying, create this user, start this service, you instead say, this user exists and this service is running. And Puppet will compare that to the state of a system, and if it's not in that desired state already, it will implement that for you. Okay, and this is implemented as a cycle. So we have our desired state in this example here. The user Elmo is present with one group ID and a different home directory from what we want. Sorry, that's the desired state, and then we have this node state, which is actually the way it is right now, and Puppet converges those two configurations until things are in the desired state. Just looking at it from another angle, this is really about how Puppet is working as a piece of software. So Puppet has a centralized service, what we call a Puppet master, and you install Puppet agents on each one of your managed nodes. The Puppet agent will be checking in regularly every half an hour, and it will first provide the Puppet master with a bunch of information about itself, an inventory, a list of what we call facts about that system. Then the Puppet master uses those facts and any desired states that you've defined to generate what we call a catalog. That's the desired end state for that system at that point in time. That catalog is sent back to the agent, and the agent works on implementing that configuration, achieving that desired state. And last of all, the report about what's happened during that Puppet run is sent back to the master to say what had happened to every resource that's under management. So this is useful in the context of a deployment where you have a blank new server and you apply your Puppet desired state to that system. and all of your software is configured, including base build configuration, middleware, and including your application, in fact. Or after that as well, it will be running typically every half an hour to ensure compliance with that desired state. So it'll be running every half an hour against the state that you've defined to make sure that every resource under management is the way that it should be. And that gets away from the way that things have been done in the past, where you would interact with the system in order to configure it, and interact with the system to fix it. And in between these periods of interaction, you wouldn't have a very clear idea of what the state of that system is. But now you're having regular reports every half hour by default, saying whether or not every one of the resources that make up what that server does are in place. So a little bit about how Puppet works. It's able to model the configuration of resources. So a resource could be something like a user, or a package, or a group on that system, or an artifact from a repository. It's able to model it and can compare each one of its attributes against the way that it should be. And for each one of those attributes, it knows how to change that to the desired state. So this example here shows Puppet inspecting a file on a system, and you can see this is its every one of its attributes, so what its permissions are, what's in its content, like a hash of its content, what the owner is, etc. And another example beneath here shows the HTTPD package as well, so showing its version. Okay. So if Puppet finds anything to be out of place, it can change any one of these attributes for you. And this is actually what Puppet code looks like. This is the most simple example of what a piece of Puppet code looks like. This is talking about a single user on a system. Okay, so it's not a programming language per se. It's really about a specification for each resource that exists on a system. So here we're describing a single user, its user ID, its group, and its home directory. And it's quite human readable. Unlike some scripting languages, it can be quite easy for some person to look at another person's code and infer the meaning of it or the purpose of what it should be doing. And when you start to build up a configuration in Puppet, you can see how in this example, we're actually including more than one resource and wrapping that in what's called a class. And a class is what gets applied to a system. So in this case here, applying the Apache class to a system will include the package and making sure that that is installed and present. And also it will include this configuration file, the HTTPD .conf file. Also making sure that the package is installed before that as well. There is a sort of a relationship between these two resources as well. So by defining all of these resources on a system, you can start to build up all of the layers, all of the things that make up a system what it is, and the way that you want it to be in any one of your environments, even if there are subtle differences in configuration between those environments. So you either define those yourself, or you can download some ready-made modules from the Puppet Forge. You assign those classes that are in those modules to a system in order to build up its configuration. And then you have a bunch of reusable configurations that you can apply to any number of systems. So once you have your application server defined in Puppet, you can go ahead and deploy as many of them as you need. So we talk about Puppet being infrastructure as code, okay? And that means by defining as code the specification of how you want your system to be, you're able to benefit from a lot of these established practices for software development that have been around and have been maturing for many years. So in this example here kind of shows how we have a particular environment in Puppet that maps to a commit ID for a group of Puppet modules on a Git repository. So some of these are mapped to development, and staging and production are currently already at this particular commit ID. So we're much more aligned now to a software development style of practice than to a traditional operation style of configuration and deployment. And treating infrastructure of code gives you all of those inherent benefits of having versioned code. You of course have historical logs to say what each change was, who that change was made by. I don't know if everyone here knows the command git blame, but you can go back over time and just go straight to see which commit was causing the issue for a particular line of code and who was responsible for that and when that change was committed. You can break all of your large changes, these big problems, these big bodies of work into much smaller changes and work on those incrementally to separate out each body of work. And of course, these are easily reverted. We can just simply assign an environment to be based on an earlier revision of the code if we want to go back in time to an early version of the environment's configuration. So I'm going to do a short demo. I think I'm doing the only demo today, so I must be brave or crazy. Okay, so just to go back to a little bit about what Puppet does, I can just quickly demo some of that, the end state enforcement here. So I've got a group of virtual machines here running on my Mac, and I'm logged into one here which is actually performing the Puppet master role. But I can work with Puppet interactively to just show me the resources on that system and to configure them. So I can do that now. So I can ask it to tell me about the root user. Puppet resource user root. And as before in that slide where I showed you something about a file here, you can see that the root user, so this is the type of resource that we're dealing with here. We have the instance of that user, the user root, and we have a bunch of attributes that map to what actually makes up that user's configuration, okay? And that's valid Puppet code, so I can pipe that out to file. And let's say that's the desired state, that's the way that things should be. Now, if I were a malevolent or incompetent sysadmin, and we had implemented Puppet, but I'd decided to go in and make a change to the way the root user is configured here. So I'm going to change the shell for that user. I can ask Puppet again, what's the state of this user? Puppet resource user root. And you can see it's reading this information live from the system. It's actually now noticed that whereas before the shell was bash, it's now sh, okay? But we still have captured in that file the way that things should be, the way they were a moment ago. So I can say Puppet apply, the contents of that file, the specification of that one resource, the root user, and I can say simulate this change, okay? Because Puppet can model the configuration and compare, it's able to tell me what it would need to do to bring a change into effect. And this is useful in a change management context because you can actually have high confidence about what Puppet is about to do before it runs. So it's giving me a warning about DNS, that's fine. But here it's actually saying, I've noticed that the value should be bin bash, but it's noticed that it's bin sh, and it would enforce that change for me if I run Puppet out of simulation mode. So I'm going to do that now. I'm going to just remove this no op flag and ask Puppet to run and enforce the desired state for me. Okay, and it's done. So that was done in 0.2 of a second. It just compared those two resources and reconciled them for me. And I can run this over and over. Unlike a script, which might break if it doesn't handle state properly, I can now just keep running Puppet, and it's actually going to check that things are in its desired state. Things are now exactly as they should be, so there's no work for Puppet to do. And typically, that's how Puppet's running. Puppet will normally run every half hour, make sure everything is as it should be. So I can move on to a slightly more sophisticated example. I can show you an example here. For example, this is a class that would describe the makeup of the OpenSSH server on a system. So, for configuration of remote configuration of that system, you might want to configure that in a uniform way across your environment. And here we've got a class called OpenSSH, and it's made up of the package that installs OpenSSH, the configuration file which describes how it should be, and we're going to say the service is running, or it should be running. And if Puppet finds it not to be, it will start that service. We've also got it subscribed to the configuration file. So if we change the configuration file for SSH in the Git repository, when Puppet runs, it will notice that has changed, install the new configuration file, and then restart the service so the change takes effect. So you can have this kind of dependency between resources. So this is a class. I can actually go ahead and start applying these to servers. I'm going to use the Puppet Enterprise console to do that. So here, I'm just going to make sure I'm still logged in. I'm not, it's timed out. This is the Puppet Enterprise console, and this allows me to perform configuration of systems and to get a look at all of the reports that are coming back from every system after a Puppet runs. So I've got a bunch of systems here. We support a broad range of operating systems. So Windows, various different Unisys, and AIX, for example, and Solaris, different flavors of Linux, of course. And I can go ahead and start configuring these systems now. So this is an overview of all of my nodes. They're all kind of color-coded to say how recently they've changed. And I can go in here now and build a group of configurations to assign to systems. Okay. So I can install Jenkins, for example. And this node is actually going to have NTP configured on there. Let's install NTP. I can edit parameters for this class as well. So the settings which are in my Puppet manifest are exposed in this console. So I can go down and set the NTP server for a system. So I can say france.pool ntp.org. And that's done. And then while I'm here as well, I can add some more classes. I'm going to run this offline, just using a repository in my environment on my Mac. And let's install Tomcat, and let's install Jenkins. Okay. And these are all modules which are available from the Puppet Forge. There's 2,500 modules available on that forge, and so I don't need to, write a line of Puppet code in order to make this happen. And I've got a CentOS node on this system, so I can configure that. I can say I'm going to configure CentOS 65B. It's my CentOS node. I can create that. And now this group of classes is going to be assigned to this system, and it will configure the system with the resources defined in those classes next time Puppet runs. Now normally we would need to wait for Puppet to run, but I can invoke that here in the console. There's this live management function, so I can reach out across the network and start Puppet happening. And this, of course, is available, not programmatically as well. All of these functions can be done programmatically. So in the context of a build pipeline, you could classify a system and start a Puppet run on that system as well. So it's just going to find the nodes on my network. Just wait for that to finish grabbing them. I'm just going to work with this one system here. And I'm going to run Puppet on that system. In fact, before I do that, I'm just going to put this in the background here. You can see this is actually a log file for the CentOS machine that I'm configuring. And so this is actually going to reach out over the network and start configuring that system with Tomcat and Jenkins. In fact, just to prove I'm nothing up my sleeve, so there's nothing on there right now. I'm going to run Puppet on there now. And you can see it's already caught that. It's already pulling down its configuration and starting to define and enforce every single one of those resource definitions that are in those modules. Okay, so that's going to happen in the background there now. And by the time that's finished, we will have stood up. We would have configured its NTP correctly with the setting that I specified, the NTP server. We will have installed some middleware and installed an application on top of that. And this is happening for the first time, but of course, in half an hour's time, Puppet's going to check that all of those resources are correct. So that'll be done very shortly. This console has reporting functionality, which I can show you more of as soon as this run finishes. But it's designed to be an interface for people to actually inspect what's happening in the Puppet environment and get that insight that I was referring to earlier, being able to look at what's been changing, what's out of place. And here I can tie this into third-party authentication, such as your LDAP or Active Directory, so that you can define what levels of access each one of your groups in your organization can have. Okay, this has finished the catalog run, so I should be able to go over to this node here. Refresh, it's installed Tomcat. And it's on beta, so let's go to Jenkins, and it should be installed, and it is. So you can see how easy it is now to build these personalities of systems and then set them out and be deployed, and then have them be enforced routinely by Puppet. Now, this has just been done on one system in one environment, but of course it's important to have the kind of the consistency between all of the environments you're using. So as a developer, you could be running a bunch of virtual machines like I am on my Mac and have Puppet configure them. And if you're using the same Puppet code to configure your development environments, your QA environments, and your production environments, then you know that all of your environments are going to be configured identically, and that your software will work in the same way across those different staging environments. So back to the slides. So we can use Puppet in a build pipeline. Okay, so we're able to use this and integrate tightly with Jenkins in the same way that in a way that KK was referring to earlier, and we can now have operations adopt those tight feedback loops for how well their things are working. Is the infrastructure being built in the way it should? If it is, you can promote it to the next environment. Okay, we can update configurations quickly. It's a matter of changing something, committing that to a Git repository, and kicking off that process through a hook. We can thoroughly test infrastructure changes. I'm going to talk in a moment a little bit about test suites, but actually, just like software languages, Puppet actually also has test suites of its own, so you can perform automated testing of your Puppet code to make sure it works in the way that it should. So you can increase confidence that your changes are going to work as they're deployed, and they will not be promoted automatically if they fail tests. And of course, reduce outages. We want to make sure that by having a similar setup across environments, that everything works as it should and you don't have any unexpected outages. So just going over to test suites. So we can actually build testing into Puppet modules so that when you start to deploy your systems with Puppet, you can make sure built-in testing is happening. So that every time you make a commit to your repositories that define Puppet modules and that contain the desired states, we can have automated testing kickoff that will ensure that each stage of this process is actually functioning as it should. It's achieving the result it was designed to achieve. Okay. So the first example of this is what we call RSpec-Puppet. RSpec-Puppet is a unit testing framework for Puppet. And this works on the catalog that is generated by the Puppet master. So just going back to what I said before, when an agent requests its configuration, it comes back to the agent in the form of a catalog, which is a sort of JSON-like file that contains the desired end state for the system. And we can make sure in an automated way that the catalog that is being generated contains the resources in the right state. And so you can be sure that every time you commit a change to your Puppet module, that if this test fails, then it's no longer doing the thing that it should. And we have an acceptance testing framework for Puppet called Beaker, named after the Muppet character. And this is an acceptance testing framework which will actually build a virtual machine, use it, configure it with Puppet, and then ensure that the resources defined by Puppet are really there in the virtual machine. So you have acceptance testing to the point where, in this example, we're going to say that, is the Apache class being applied? In fact, the Apache service should be running, and that test will fail if it's not found to be running on that system when Beaker runs against it. So having this kind of powerful infrastructure code that's self-testing when tests are written for it allows you to have environments that can be very easily stood up, whether that's here on my Mac. My demo environment, for example, is made up of a bunch of Puppet modules that stand up the whole Puppet infrastructure here. And you could do the same, for example, in DR. You could point Puppet and classify a whole new set of systems to run your applications in a different location. Migrations are easier too, because every single aspect of your configuration can be codified, and therefore moving to a new location is as easy as actually just classifying new systems with those configurations. And of course, building new development environments. I went to see a customer yesterday that has, one production environment, a few staging environments before that, but over 100 development environments, basically one for every developer. And by using and checking out the same infrastructure code to define how their environments are set up, you can make sure that there is a good uniform standard across all of those environments. So just to underscore that, developers are basically going to be working on perfect replicas of production and not failing through differences in between those stages. In the context of a build pipeline in Jenkins, we can now build up a shared build pipeline that's triggered by a commit to Puppet code or triggered by a commit to your application code, and that builds a system, tests that the system is configured correctly with Puppet, then installs your application, and then tests your application. You have this single pipeline. And here we can see both, you have your developers and your operations groups using the same methods, the same disciplines, in order to make sure that your tests and your continuous delivery is really realized both at the infrastructure level and at the application level. So now you have this shared goal of nobody breaking the build and everyone having the same, getting rid of any sort of blame culture that could exist between groups in your organization. So there'll be no kind of, well, it was, it's your app. No, it's your infrastructure. You can now actually have full transparency about how this stuff is working. And you can now focus together on the goal, on the business goals, and use the same methods to achieve them. So just to sum up, Puppet is really about declaring desired state for a system. It's not like scripting, it's not like these gold image tools we've had before. It's really about enforcing and always working to change and converge on a new desired state. You can conversion control Puppet, and so you can have all of the benefits that version control gives you. And of course, there are testing frameworks that can be used side by side with tools like Jenkins in order to test and deploy both your application and your infrastructure code. I've enclosed some links here. This is going to go out with the slides for everyone. And just a kind of shameless plug, it's PuppetConf in 2 weeks' time. So stay tuned, there's going to be a lot of announcements then for new stuff surrounding Puppet, and there's going to be some great talks that can all be watched on YouTube. Does anyone have any questions? Yeah? Sure. Okay, so yeah, so 2 questions there, just for everyone. The first one was about rolling back configurations. So the ability to roll back configurations isn't really, it kind of goes against what Puppet is about in a way. So you can achieve that goal, but not by like hitting a button to roll back. So with Puppet, you're always working towards a new desired end state. So you have a new version of your Puppet code each commit you make, and that is a new end state. Now, if you find that you want to go back 2 versions, you just check out the commit that worked, the one that you want to go to, and that is the new end state. So it's not a rollback; it's more a roll forward to the way it used to be. Does that make sense? I know it's a nuanced difference, but it's worth pointing out. The second one was about going through the history of configurations. So just to go back to my console here. There we go. Don't know what happened there. So my master here basically should have a. It's my Mac crumbling under all the work it's having to do. It's going to have on it a report for every Puppet run that happens. So that Puppet run will describe every single one of the resources under management and what state they were changed to. So between the Git commits that describe these states, all of the catalogs also are stored as well for every Puppet run. And of course the reporting, you have a full view of who made the change, what changes were in that particular Puppet run, and what the outcome was. That's okay, I can repeat. Okay, I'll answer that one first. So, you know, in my experience, it is, you know, the systems administrators are taking ownership of or taking ownership of Puppet infrastructure in general, because it plays primarily in the infrastructure space. Now, it differs from organization to organization who's responsible for just the systems, or the systems and the middleware, or the systems, the middleware, and the applications produced by another team. So it does vary from organization to organization who is responsible for defining all of that. Sometimes you see in a company they will just, the development team will just describe their application as being delivered through an artifact repository. And then as long as the operations team knows how to handle that installation, they can model it in Puppet and take control of that. But we do see, sometimes it being taken up to a level by the infrastructure team. Puppet can also run as a non-root account as well, so applications teams can have, a degree of control over a less privileged account for just their own Puppet manifests as well. So it does vary from place to place. Primarily, it's the systems administrators, I would say, working with Puppet at the moment. Well, you can achieve sort of continuous delivery of your Puppet manifest, because you are basically triggering a build pipeline every time you're committing Puppet code, because the running state of your software is going to be made up of the underlying infrastructure and middleware and the application. And so if you're changing something about Puppet, then you really are changing something about the environment the application runs in. So if you have a single pipeline, or two parallel pipelines, one which actually tests Puppet code and then the application, or one that deploys Puppet code and then runs tests against the application, then you are achieving continuous delivery of both of those things, both the infrastructure code that everyone is collaborating on and the application code as well. And you're using the same tools as well. Yes? Yeah, that's a great question. So for everyone, that was a question about whether or not Puppet can really handle anything underneath the operating system layer. The answer is yes. So we provide tooling in Puppet Enterprise for cloud provisioning. So we can reach out to the APIs of Amazon, vSphere, Google Compute Engine, etc., in order to spin up a virtual machine and then install the Puppet agent on that and classify it as a single operation. And that could be, for example, executed as a step in a build pipeline in order to actually hand off to Puppet to handle the configuration and run testing. Things like Beaker can use tools like Vagrant to spin up and handle automated testing. And we also have in tech preview at the moment a bare metal provisioning tool called Razor. There's quite a lot of talks about that online, and we can talk after this about that if you're interested. And that can handle bare metal provisioning of hypervisors of full operating systems using sort of a Puppet style methodology. So yes, the short answer is yes. You can handle all the way from nothing, and generate instances and install operating systems and begin deployment above the OS layer with running the Puppet agent. Please, yeah. Yes. Sure. Yeah, great. So we have the idea in Puppet, this idea of a resource abstraction layer. I know that's a techie term, but the idea is that when you describe, you use the word package, and if the agent interprets that in a way that's relevant to the system it's running on. So on Windows, that could be an MSI or a Windows exe, for example. On Red Hat Linux, it could be an RPM or something from a Yum repository. And Puppet makes certain assumptions about which method you're going to use, depending on the system you're going to run on. You can write manifests to have conditionals in them to say, if I'm running on SUSE, do this. If I'm running on Debian, use this method or use this package name. You can also override that and say that I want to serve the RPM from this URL as well. So there are multiple methods of deploying down. Generally speaking, though, Puppet isn't it's not a software repository necessarily. I mean, it can function as that by holding files and serving files, but we assume the presence of a software repository. You'll see there that I was saying that we want to ensure that HTTPD is installed, but when Puppet actually tries to implement that, it's going to run Yum, and if Yum's configured to find that package, then it's going to install it. And of course, Puppet can be used to configure Yum as well. So, okay. Any more? Yes.
Hi. I'm just wondering if you have any data on the ROI for a company to invest in Jenkins and so on. Do you have any data?
Sure. So we have multiple case studies of people implementing Puppet. I normally show those slides off at other events as well, more sort of sales type events, to talk about companies. I can show you those after this. It's really, we have people saving time and money. That's what it comes down to. But I think what's more fundamental, you've probably heard a lot about that today, is that achieving the cultural shift is probably the bigger deal, and it's the bigger win, I think, as well, because I'm not sure how easily you can measure that really, but we certainly have figures about people saving money and not needing to use certain software anymore, and I can show you those. But yeah, just to certainly underscore that it's as much about changing what you're doing as installing and using a tool. Any more? Okay. Yeah. Yeah. Yeah, just for everyone else, that's something we see a lot of. It was just about, how do you kind of overcome those kind of embedded practices of people kind of keeping multiple versions by timestamping their files and things like that. I think, Git is kind of quite an amazing tool, I think. It's kind of, and it can be complex if you go deep enough, but if it's actually quite easy to learn the basics, and until you have it, it does look scary. I'd admit that. So I think getting people to kind of see the benefit and being able to roll back and move between branches, and as soon as the collaboration starts happening, I think that's really where it takes off. I mean, people can get used to working on their own with it and use it as a convenience to keep multiple versions and not having to timestamp things and things like that. But really, the real benefit is through the collaboration and also the hooks, the actual automation hooks that can be achieved through it. When you make a commit, kick off this process. Really kind of unleashing the power of it is where you're going to convert people, I think. So just show it off, I suppose, is my answer. All right. Thank you, everyone.